Student views on imaginary and complex numbers. Methods. 10 college students of varying academic levels and majors were surveyed on their knowledge of both imaginary and complex numbers. The first question was, have you ever seen the letter I used in math, and if so, what does it mean? 90% of the students recognized that I stands for an imaginary number. Only 30% of students gave an adequate definition of what I actually is. The gray boxes below show some student samples of answers. The next question was, where are imaginary numbers used, and why do we have them? 20% of students thought that I has no purpose or use. 20% of students had seen them used in engineering. 30% of students thought that they were useful in upper-level math courses, such as college calculus and above. Again, the gray boxes show some sample answers. The next question was, what is the difference between an imaginary and complex number? 60% of students don't know or cannot remember the difference between the two. 30% of students gave their response that complex numbers contain both an imaginary and real part. This was the correct response we were looking for. Only 10% of students gave an incorrect response. Again, the gray boxes show student sample answers. The last question we asked was, have you ever seen a graphical explanation of I? None of the students surveyed had ever seen a graphical explanation of I.
Now we will look at a graphical representation of what I is. This is the complex plane, which includes both real and imaginary numbers. Real numbers go horizontally, and imaginary numbers go vertically. So let's break it down by first looking at the real number line. Looking at the graph, we can see that multiplying 1 by negative 1 can be thought of as a rotation of 180 degrees, about the origin, 0. This is labeled rotation 1. Another 180 degree rotation would be multiplying by negative 1 again, which gets us back to 1, which was 360 degrees. We can write this algebraically by writing negative 1 times negative 1 equals 1, or negative 1 squared equals 1. When we're looking at the rotations, though, we can see that 180 degrees plus 180 degrees equals 360 degrees, which is where 1 is. For square roots, remember that the square root is a number that can be multiplied by itself and give us the number that we are taking the root of. So in this case, the square root of 1 is negative 1. But you can also have a square root of 1 as well. Since negative 1 times negative 1 are the same number, and multiplied together give us 1, then negative 1 is the square root of 1. So now looking, how would we get to negative 1 in two rotations? Well, since negative 1 is a 180 degree rotation, then we need two rotations to get to 180, because we are looking for the square root. So we can see that we need two rotations of 90 degrees to get to negative 1, since they have to be equal. So what then can we multiply to get 90 degree rotations? Well, there's a problem. it's not on the real number line anymore. So what do? So instead we'll go ahead and draw in our 90-degree rotation. And we'll actually label I. So together with this new number line and the real number line, we create the complex plane. This new number line we made is imaginary numbers. So we can see that the way we've labeled it as I is a 90-degree rotation. So if we take two 90-degree rotations, we have I squared equals -1. Since I squared equals -1, if we take the square root of both sides, then I equals square root of -1. So that's all there is to finding out what I is.